A warm welcome to all my students. Today I am going to explain about switch mode power supply. In part 1, I am going to explain about introduction to switch mode power supply and two types of switch mode power supply, half bridge and full bridge. In part 2, I am going to explain about the other two types of power supply, push-pull SMPS and flyback SMPS. So now I am going to explain about switch mode power supply. Before going to explain about switch mode power supply, everyone you have to understand what is meant by power supply. Power supply is an electrical device that supplies electrical power to an electrical load. The primary function of a power supply is to convert the correct voltage, current, and frequency to the load from a given source. So there are various types of power converters, power supply. One is AC to AC power supply. Second one is AC to DC power supply. Third one, it is called as DC to DC power supply. Fourth one is DC to AC power supply. These are the four types of power supply are called as power converters. I am going to explain about AC to DC power supplies. Now you take two examples. First example, I want to charge my mobile phone. So the mobile phone requires 5 volt DC. But in all our houses, we are having the source voltage is 230 volt AC. So this voltage cannot use to charge the mobile phones. So I need a power supply. So the mobile phones, it requires 5 volt DC. But in our houses, the input voltage is 230 volt. So what I am doing is, this is called as a power supply. What is the function of the power supply means? It will convert this 230 volt AC into DC. So this is called as AC to DC power supply. It is converting the AC to DC as well as it is reduce the voltage. That is the function of the power supply. So this is the second type of power supply. I am having one fan here. This is called as load. This fan requires 100 volt AC. 100 volt AC. But here in our house, the input voltage is 230. So I want to use AC to AC power supply. What type of power supply? AC to AC power supply. This will convert 230 volt AC into 100 volt AC. This is given to a fan. Next, what is meant by switch mode power supply? Yes, SMPS is called as switched mode power supply. It is an electronic circuit that converts power using switching device that are turned on and turn off at high frequency, and storage components such as inductors or capacitors to supply power when the switching device is in the non-conduction state. The switching power supply have very high frequency compared to the normal power supply. Here I have shown two types of power supply. The left hand side, this is called as switch mode power supply, and this is called as linear power supply. In earlier days, we are using the linear power supply. So this is the linear power supply has a lot of disadvantages. Due to these disadvantages, we are now moving to the SMPS. So here we are having AC input. This is given to the transformer. This transformer is a step up or step down transformer. Here we are getting an AC voltage. This AC voltage is given to the rectifier. It will convert into DC. Here we are using is a filter circuit. It will use to remove the filter ripple content. And here we are having voltage regulator. So you will get an unregulated DC voltage. Here we are getting a regulated DC voltage. Here AC to DC rectifier is used. It is operated in 50 to 60 hertz. Here the filter size is very large. The size of the circuit is big and weight is very large and it is less efficiency. So the linear power supply has less efficiency, more weight, size is large, filter size is large. Due to this disadvantage, we are moving to the switch mode power supply. Here we are having AC input. This is called as DC output. A rectifier is used. It is used to convert AC into DC. Filter, it is used to remove the ripple content in the DC. Next, you are using one inverter. Inverter, it will convert DC into AC. That AC is given to the transformer. This transformer, it is used for isolation purpose. The transformer is in step up or step down. And here we are using a rectifier. Once again, it will convert AC into DC and filter is used to remove the ripple content. So now this is called as a closed loop system because I need a regulated DC output voltage. So if the output DC voltage I require is 5 volt, if it is less than 5 volt means it will give the signal to the controller. So the inverter on time will get increased. So what will happen means this output voltage will get increased. Suppose your output voltage is very high, this controller it will be switch off this inverter. So the input to the transformer is less. So automatically voltage will get reduced. So this is called as a functional block diagram of SMPS. So due to the need of power supply, because in nowadays all electronic components we need it is operating different voltages, so we need a power supplies. So here the SMPS is developed in 1960 for space vehicles. The production of SMPS is nowadays 70 to 80% higher due to these advantages. It is based on the chopper principle. The output voltage is controlled by duty cycle. What is my duty cycle means? It is called as alpha. Alpha is nothing but T on divided by T. T is called as total time period. T on is called as switch on time period. There are two types of techniques used: PWM techniques, FM techniques, pulse width modulation techniques or frequency modulation techniques. The size is less, weight is also less. SMPS. In SMPS, we are using diode as a diode rectifier is used. It is operated in high switching frequency. So the filter size of the filter component is very small. The power transistor, there are in the chopper, in the SMPS, we are using transistor. If you use transistor, the frequency is 40 kilohertz. If you are using MOSFET, the frequency is 200 kilohertz. In the transformer, we are using ferrite core is used in the transformer. The filter size is reduced and transformer size also reduced. We can see the comparison between linear power supply and switch mode power supply. Efficiency is high in SMPS, here it is low. Voltage regulation done by the regulator, here it is by using feedback. The magnetic material used in transformer is steel alloy or CRGO core. Here ferrite core is used. Here more electromagnetic interference. Here it is less. Here it is transient response is faster. Here it is slower. Radio frequency interference no. In SMPS there is an interference is available. The circuit is more complex. SMPS it is less complex. There are 4 types of SMPS: half bridge, full bridge, push-pull, flyback. So now I am going to explain about only half bridge and full bridge. In part 2, I am going to explain about push-pull and flyback. These are the applications of SMPS. Full bridge is used for high power application above 750 watts. Push-pull is used for LVDC, low voltage DC application. Flyback converter is used for low power application below 500 watts. Half bridge is used for high voltage DC applications. It is used in computers. It is used in security systems, machine tools, railway system, mobile phones, battery chargers, in vehicles, It is used for lighting purpose, etc. These are some application of SMPS. Now I'm going to explain about half bridge converter. Half bridge converter, this is the output, this is called as VO is called as output voltage. Here it is called as VS is the input voltage. This is the another component is called as rectifier, uncontrolled rectifier, that is AC to DC, two capacitors C1 and C2, two switches M1 and M2, and one transformer, it is called as midpoint type transformer, and next is called as full wave bridge rectifier, that is called as midpoint full wave rectifier, filter circuit, this is called as control circuit. Now I am giving this here AC supply. Here we are using two capacitor. The capacitor, you assume that VS is equal to some 100 volt. By using this uncontrolled rectifier, it is converted into DC 100 volt. Here I am using two capacitor. The range of this capacitor is half of the input voltage. So that is called as 50 volt capacitor. Two capacitors C1 and C2. Initially there are two switches M1 and M2 is called as switch. The switch we can use as transistor, MOSFET, IGBT, SCR, etc. The switches is controlled by this control circuit. Control circuit 1 is connected to switch 1, 2 is connected to 2. So this is called as control circuit. So now both the switches are off. Now the supply voltage will go and store in the capacitor C1 and C2. So example 100 volt is the input Vs. So 50 volt will be stored in C1 and 50 volt will be stored in C2. Now I am turned on the switch M1. M1 is turned on and M2 is turned off. So here the current will flow from capacitor positive, switch, transformer, and it will come to capacitor 1 negative. So the current will flow to this transformer primary. So the voltage is called as 50 volt. The supply voltage is 100, but the half of the voltage will go to the primary. Now you will get a secondary voltage. So V2, you know what is my transformer ratio? V1 by V2 is equal to N1 by N2. From this V2 is equal to Vs into N divided by 2 into N1. This is the formula already you have studied in the transformer. So here we are getting plus and minus. So plus and minus. Now the diode D2 is reverse bias. Diode D1 is forward bias. So the diode D1 is on, D2 is off. So now what will happen means the current will flow from positive diode and filter and it will go to the load. Now you turn on the switch M2. When the switch M2 is turned on, so the current will flow from plus, it will go here plus, next it will come here, next it will go M2, next it will come to negative. So the primary polarity will get changed. So here the top will be minus and bottom will be plus. So the secondary voltage here will be minus and here plus. Now the diode D1 is reverse bias and diode D2 is forward bias. So D1 is forward bias. So D1 will get on. So the current will flow from plus. It will go to the filter, load, and it will come to the negative. So like this, continuously the switch M1 is on and M2 is on. So you will get as positive and negative voltage in the secondary of the transformer. By using the rectifier, you are converting that AC into DC. This filter, it is used to remove the ripple current, and here we will get an output voltage. Now I need a regulated output voltage. If the voltage is high or low, this control circuit, it will be control the two switches M1 and M2, so that we will get a regulated voltage.